In this video, I wrote a test to make sure that when I deploy my inbox contract, I get some initial value for the message passed in. This is definitely going to be my first real test that I record. I know this was a lot of videos to build up to this, but again, I'm covering a lot of different topics here at the same time, such as contracts, Web3, and the test network, and Mocha. So these videos may be going slow, but honestly, it's for the best. So as you can see, I added another test down here while offline. Another it statement is what I added here. I wanted to make sure that when I created a new contract, I got a default message. So I gave it a description of it as that it has a default message, as you can see here. I also wrote some code to somehow look at the inbox and somehow pull out the message property in the Solidity code. I'm referring to this property here. I don't know if you saw my video where I was using Remix, but in it I show how I can make access of the message property by clicking the message button. By doing so, I was calling or invoking a method on contract to gain access to the message instance variable. You will also recall, because the message variable is public, again, you can see it here, it's public, I automatically got that method generated for me. So I'm going to pull up a diagram just to kind of illustrate what I'm trying to, my point here. I'm going to share that with you. All right, let me increase the size here. All right, so I used this diagram some videos ago, and remember that there are two ways in which you can invoke a contract function. And the two ways are here, calling a function and sending a transaction to a function. We can call a function and call it anytime you want to simply read data out of a contract. When you call a function, you instantly get back some amount of data, or relatively instantly anyway, because when we call a function with Web3, it's still an asynchronous request, but we don't have to wait for any transaction to be confirmed by a network. So it runs relatively instantly. On the other hand, we spoke about how to modify a contract data when we send a transaction to a function. So I'm thinking about how to retrieve a message. I think we want to call a method on our contract, right? Because we want to retrieve a value on our contract, and we don't want to modify any data that's tied to it. So head back to the code and be here. And so the first thing I did, so this is why I wrote this code, which attempts to call a method on a contract. And so the first thing I did, though, is to mark the function as being async here. And calling a method is asynchronous, so we have to assume that calling this method is going to return a promise, and we have to wait for that promise to be resolved. So I'm implementing the async await syntax to wait for this message property to come back to me. So I assigned the this here, the initial message property to this variable, and then I said await inbox, right? dot methods dot message dot call. So let's look at this carefully, because this line of code is something that I'm going to be writing many times throughout these videos. So first, I reference the contract. And I think that's clear enough that this is an instance of a contract. And this is the contract here, inbox. So when I say I'm referencing the contract, I mean right there, inbox. So the inbox object here that represents the contract that exists on the blockchain. And my contract has a property called methods. And in a previous video, I went over some of those properties in the command line terminal. And so you'll be able to see what I'm talking about if you watch that video before watching this one. So my contract has a property called methods, which is an object that contains all the different public functions that exist in our contract. So if I go over to the Solidity source code, I would have two methods defined on my contract. I would have setMessage and message. There are two methods that are tied to my contract. Those are the two that are tied to my contract right now. So you can see I'm referencing the message property right here. And if you wanted to somehow call setMessage instead, rather than calling methods.message, this would be right here, this would be methods.setMessage. So when I call this message property here, I placed one set of parentheses here. When I call message, I need to have two sets of parentheses, this one and this one. The first one that is tied to the actual method, and then a second set of parentheses that is attached to the dot call. The way to understand what these two sets of parentheses are doing here is that the first set will take in any argument that this function might require. When I try to retrieve the message property off my contract, that doesn't require any argument to be passed to it. However, when you look at setMessage here in the Solidity file, this one does require an argument. So if I'm trying to call a function that requires some arguments, we would pass those arguments into the first set of parentheses here. The second set of parentheses is to customize the transaction that I'm attempting to send out to the network. If this was actually me attempting to send out a transaction, I might pass in an object that specifies exactly who is going to pay for this transaction and how much gas to use. I'll come back to discuss these two sets of parentheses in subsequent videos. So this line of code here will retrieve my message, and then the last thing I did here was to assert the value of the message. So when I first initialized my contract, I gave it an initial string of hi there. So you can see it up here, right? So this is where I first initialized the contract. So when I get this message back, well, it should definitely be the string of hi there. And that's why I have here message and hi there. So I wrote assert.equal message and hi there. So we could make it more robust. Like I might decide to assign the string hi there to a variable. So maybe I could do something like const initial string, and then just call that hi. It's called hi there, right? And this is a way to make it more robust. And then I could actually reference this variable of initial string down here, right, in the assertion. So this is good if a future developer comes after me and does not like this string of hi there and they want to change it. If that developer changed it either here or here, that would break the application. So by instead referencing one common variable, that's a way to ensure that that doesn't happen, because then when the developer comes after me, does the change here at the variable stage, then it'll this variable would be what gets placed in here, and so nothing will break. But I'm actually not going to do this. I'm not going to implement this, and the reason why is because this application that I'm working on, I know that it's not anything that's going to scale or need to be scaled at a future point in time. And also, I'm the only developer working on this application. All right, so I'm going to go ahead and run the test. So head over to my terminal, and I'll go ahead and do npm run test. And there may be a delay, and if there is this delay, yep, there's the delay. It's coming from the compilation process, that's why. So the test looks like it's passing from what we see here. It deploys a contract and it has a default message, and two are passing. So that means that anytime I deploy an instance of my contract, I am definitely getting some default message set on this instance. Okay, this looks good. In a subsequent video, I'm going to write one more test live. When I do it, I'm going to be recording it. to ensure that, and the idea behind that test that I'm going to write in that next video is to ensure that this can be updated over time and then retrieved, um, and then, to retrieve it again off the instance. All right, I'll see you then.